Hello and welcome to this new video in which we are going to see how to perform the diagnostic test in linear regression using SPSS. So it's very important to test for error term diagnostic in linear regression because there are some hypotheses, normality, homoscedasticity, as well as non-autocorrelation of error term that are very important in the stability of model. So the normality test is very important. It's some hypothesis that is hidden behind regression that is very important in the significant test of coefficient, the way that the student test that is used to test for coefficient significant is based on the hypothesis of normality of error term that is used to build the student statistics in order to test for coefficient significance. So it's very important. So though to test for the normality of error term, it's very important also to test for homoscedasticity because homoscedasticity hypothesis rely on the constant of variance of error terms. So is the error terms variance is not constant, it's not good because we have a model that error term is not stable. So we need to have a error term that have zero mean and constant variance in order to very well master the error term. So the last hypothesis, which is non-autocorrelation, is important because if you have error term that is previsible using previous value of error term is not good because it means that we can improve the quality of model. We can try to stop this capacity of error term to predict is value using its previous value. So it's important to check those three hypotheses in order to have a model that everything coefficient, for example, are interpretable. So it's the first time you are watching one of my video, to subscribe to my YouTube channel and activate the notification bell in order not to lose the next videos. So we have a data set in which we have many variable denoted x1, x2, x3, y1, y2 to y6. Y are for explanatory variable and x for independent variable. So we'll estimate randomly a model using those variables. So the name of variable are not important. What is important here is to see how to check for hypothesis to error terms. So we go analyze. Then regression and linear regression will select, for example, for independent variable y3. So as independent variable, we'll select y1, 2, and 3 and put it using this arrow in the independent section. So what different element we need in this process? So we need to in statistic, for example, it's important for us to have a Durbin-Watson statistic. So we'll select Durbin-Watson to have a Durbin-Watson statistic in order to use it to compare to critical values that are in Durbin-Watson table in order to take the decision is whether or not we'll accept or reject the null hypothesis of non-autocorrelation. Then we click on continue. What will we plot in this section? We need to test for homoscedasticity. So for homoscedasticity purpose, we'll plot the standardized residual that we'll put on y-axis and in x. So we rather put on x-axis, and on y-axis we'll put the dependent variable standardized prevision in y-axis. So we'll plot the histogram of error of this residual, as well as normal probability plot to see how much the normality, the curve match with the histogram for normality purposes. So we click on continue, and then on save, we'll save the standardized residual, because we'll use that standardized residual in order to test for normality of error terms. So we'll also on predicted value of the y variable test for say standardized value to homoscedasticity test, even though in the selection of variable we are already asked for the curve of standardized residual of the plot of the scatter plot of residual and standardized predicted value of y variable. So we can drop this selection about standardized predicted value, and then we click on continue, and then on option, we don't have any option here to select for the hypothesis verification. So we can then just click on OK, and then we'll have the result of our estimation of the residual of our linear regression model. First, we'll have our Durbin-Watson statistic that we will use to compare in Durbin-Watson statistic the critical value to help us interpret our autocorrelation test. So we have a Durbin-Watson statistic here is 1.19. So our Durbin-Watson statistics is here. Another coefficient we have also element on coefficient that are not interesting us for now. But what is interesting us now is, for example, the PP plot for regression standardized residual to see if whether or not the curve match with this diagram, with this curve. So we can see that the curve match very well with the line. So we'll verify this hypothesis in our normality test, analytic normality test. Here is just a graphic test of normality. We'll confirm this hypothesis in our the analytic test. So we have a scatter plot of residual on regression standardized predicted value. And you can see that the scatter plot is very homogeneous, that because you can see that the value are in rectangles or in the rectangle, and we can now according to the representation say that our scatter plot is very homogeneous. So we can just accept the hypothesis of almost scarcity of our error terms. So what hypothesis are we going to check now? So we have also in the analysis asking SPSS to generate the standardized error term in our parameter. So we use this new generated variable of standardized error terms to test for normality using Shapiro weight and Kolmogorov mean of test. So we go on analyze descriptive statistics and then explore. So we select our standardized residual, put in dependent list in statistics. We have nothing here to select. In plot, we select normality plot with test. So we'll have the result of normality test. So we click on OK and then click on OK, and you can see that here are the result of normality test. First of all, we have curtosis here and skewness, that element that in base of which the normality tests are built. We have, for example, in Kolmogorov's Smirnov test that the significance is here 0.2. The Shapiro-Wilk significance is 0.4. That are all more than 5%, meaning that the hypothesis of normality is verified, is satisfied in this regression model. Meaning that we are happy about the normality of our error term. The last hypothesis that we are going to check here is you can see that the normality plot standardized residual that really match with the line, confirming the analytic test of normality. The last hypothesis that we are going to verify is autocorrelation using the Durbin-Watson critical value, which is 1.19. So we have here a Durbin-Watson table here. We have 3 explanatory variables, meaning that K here is 3, and we have in our data set 36 individual, meaning that in our Durbin-Watson table we'll select the line 36. So critical value for 36 observation and 3 explanatory variables are 1.29. The critical value, Durbin-Watson critical value is 1.19, which is less than the lowest value of Durbin-Watson. Let's go here on Durbin-Watson statistics interpretation. We can see that the different cases are when the Durbin-Watson statistic is less than the lowest value. There is significant evidence that the error terms are positively autocorrelated. So we are in these cases of Durbin-Watson, meaning that we are not happy about our model because the error term, the test of error non-autocorrelation, the test of non-autocorrelation confirm. We reject the null hypothesis of non-autocorrelation, meaning that our error term are autocorrelated and the correlation is positive according to Durbin-Watson statistics, so that we are not happy about our model. We confirm the normality, but autocorrelation is not good. So we need to try to change our model using, for example, the generalized display in order to correct that autocorrelation. So for now, we cannot interpret the hypothesis or the result of our model due to the violation of one of hypotheses that is hidden behind the linear regression. So that's it for this video, which the purpose was to show you how to estimate a linear regression model and test for diagnostics on residual. If you have not done so, do subscribe and activate the notification bell in order not to lose the next publication. Do let a thumbs up. It will be a pleasure to know that all efforts we are making are helping improve your statistical model for social sciences level. So let us see you very soon in a new video.